Joe Perry-Clark here this afternoon, giving us the last talk for LCA 2013. She has some interesting statistics to show to us. Thank you very much.
Thanks. Hi. Oh, thank you. Thanks very much for turning up to my talk. This is also my first LCA presentation in the mainstream as well. It's a little nerve-wracking. So I'm going to be talking about patch deployment and the patterns that patches can make in Australia and New Zealand, I hope. So who am I? I'm Joe. I work as a Unix sysadmin, among other things. The company that I work for maintains some critical infrastructure. I like to describe my job as being a professional pessimist. As a sysadmin, a lot of what you do is planning for disaster, hopefully before the disaster happens, because usually when it happens, everyone's just sort of running around shrieking. I'm also a recreational doomsayer, I suppose. I talk about security a lot, and not a lot of people listen all of the time. I also am partially responsible for KiwiCon, which is New Zealand's best and only hacker conference. It's a bit silly. Although those guys are New Zealanders, so the Australians actually not that much better. Valid URL. So as I said, I work as a Linux sysadmin. I work for Catalyst IT. They sent me here, and thank you very much for sending me. Hi guys, if you're watching on the live stream. But they're not actually responsible for this research. All of opinions, ranting, miscellaneous swear words, and or threats of violence are entirely my problem. The reason that I want to make this distinction is a lot of words that happen to be legislation and are rather boring, but the relevant bit is this. There is no case law in New Zealand for this yet, so under some interpretations, depending on a malicious reading of it, I mean, it could include Google's search bar, for instance. It is recklessly showing you how to download software that could be used to commit a crime. And what I'm talking about today could also come under this category, depending. As I said, there's no case law. If you ask a lawyer about this, then they kind of go, oh, hell no, and then they won't talk to you anymore. So, what this is basically is a weaponized Nmap scanner that has got a web front end on it. I think it's nearly up to version 3.3. Goes through, I think, the top. Scans by GeoIP. There's a lot of ways to determine what is a country in cyberspace. So we just outsourced the problem and made it Maxmind's problem instead. It looks something like that. Import scan country. Python is awesome. And then you go through and you list all the ports that you want it to look at. The web interface looks kind of like this. You can see the host stats here. Like for Australia, I think we got 4.2 million hosts. There is a host of the day, which is conveniently running ProFTPD. That may be unpatched, I'm not sure. There are a bunch of potted searches here, so you can say, look for writable SMB shares, LDAP, anonymous LDAP binds, that kind of thing. I think we got, about 7.2 million hosts in it now. And application layer data for 40 points. Is it just me, or is that shaking a little bit? Across. Okay. It also does graphical banner grab. There's a little Python mouse wiggle coded in to get past people's screensavers. Occasionally you find people logged in, which is really, really disconcerting. So if you're a terrible hacker, cyber terrorist, that kind of person, you would probably use it for target location. You'd say, give me a list of things that I can exploit. If you wanted to bust out a worm or something really quickly, you can use that. or scope expansion. You can say, well, the company that I'm doing a test for, or the company that I'm trying to access, I know that they've got this stuff, but if I look around, say, shared SSL certs or org numbers, that sort of thing, then I may be able to find another way to get a toehold on their systems. For Blue Team, it's really good at finding out what your actual perimeter is. There's always going to be some orphaned or legacy boxes on your network. I think we found one that was about 3 corporate takeovers old, and you could still sign up, and the form still worked for them to send you an actual floppy disk with the internet configuration on it preloaded for you. It was kind of sweet. It's also good as a sysadmin because you can look up your stuff and then you can look up your friend's stuff and then laugh at them. So anything running on 3.1.3.3.7 is probably a good sign that you've got some forensics to do. But however fun it is looking for outliers and looking for stuff for particular organizations, particular companies, as I said before, it's got like, I think 7.2 million active hosts on it across all of those countries. 4.5 million application layer records for the 40 most active ports. We've been scanning New Zealand for about, a loose consortium of concerned people has been scanning New Zealand since about 2009. So there's a lot of information in this database. And so however entertaining the outliers are, they're not the majority of the data set. And so I was wondering what's getting lost. Is there any large-scale patterns that I could possibly identify if I look at this data set? So I decided, is it possible to identify the operating system and the patch level via the banner grab? Its actual name is low-hanging kiwi fruit, but I'm just going to refer to it as LHKF. And if I can identify the operating system and the patch level, what does this look like? Does it look like anything? Is it kind of random? Are there any patterns at all? Is the lack of patching a pattern in some cases? I chose patching because of the DSD strategies that were mentioned in a couple of talks before, I think. And the original document they were the first and second, patch your operating system, patch your application. And the most recent revision, they're the second and third. So it's something that the DSD takes very seriously and right up there with application whitelisting. And I would probably thank them if they could actually identify who they were. They probably can't. But it's also a sign that someone's looking after the system. At some point there is a list of machines somewhere and someone is going through and marking them off and saying, well, yeah, we'll patch that one, that one's up to date. I realise that this is problematic because I'm not going to ask people to put up their hands, but I have occasionally heard that it's too critical to patch, or we can't afford it to be broken, we can't really arrange an outage window as fast as you would like, that kind of thing. So it's not a perfect way of checking that the box is on someone's radar, but it's pretty much all I can get without like knocking on people's doors and telling them to give me the info. So, for the first question, can you identify the operating system and the patch? And the operating system, the patch level, running applications, Telegram. Kind of. Sometimes it's surprisingly hard to find. I thought someone would have maybe come across this problem before and made some useful tables that I could just import, but no. And in searching for the strings, I found some interesting stuff, like this particular string here. It's not really very confidence-inspiring when the first one is a post on full disclosure, and second to asking about how to hack it. But I harassed other sysadmins to tell me about this, find out the strings from their systems. I ended up spinning up a couple of my own VMs. So I got it mostly. There's problems with custom banners. It's about 300 of these on the Australian internet. I don't know why, but I don't know what that system is particular, operating system or patch level that's running at, and they don't really seem to be that friendly. Other things may float around inside an ISP modem pool. Like, it'll be the same host, but it'll be coming from a variety of different IPs by scan. So I'll get like duplicate records for what is effectively the same host. Another problem is configuration settings. But it's not really a problem, because in my usual job I would force people to put this into the deployment. So this, which is one of the most, this is from the data set, this is real. It's very, very chatty. But if you go there and set that, all of a sudden all you get is Apache. So there's, depending on how the boxes are configured, I may not be able to tell. There is also variation between services on the same operating system. You can use this to correlate, which is pretty useful. Say Microsoft IIS 7.5, but if you know the box is also running SendMail, this here is a Windows Update status string as well. You can get an exact patch level from that. So there's also non-unique banners. CentOS, Fedora, OpenSUSE reuse their open SSH banners, or they could also be an embedded device or a custom compiled binary. You can also correlate with them. There's Apache banners, for instance. CentOS, Fedora, OpenSUSE also all have unique Apache banners, so from there you can infer stuff about the SSH. And also non-standard ports, which I haven't really got into because, as again, they're probably outliers. The majority of the data, I suspect, is kind of glommed in the middle. And I made a lot of spreadsheets, and it was really boring. A lot of spreadsheets. Just matrices of strings relating to particular distributions. And so, what does it look like? Like that. But yeah, so, okay, whistle-stop tour through ports in Australia and New Zealand. SSH port 22 is missing. Okay, so what that is supposed to be is a graph showing Debian and Ubuntu versions in New Zealand scanned over time. Basically what you get is huge spikes where the distros come out for both of the operating systems. For Debian, and you can see them moving forward a bit as more hosts get deployed, and they're up to date when they're deployed, and then they kind of bit rot back, and some fall off, and some get patched. But I found it pretty interesting that Debian always has a little bleeding edge here. They have most of the Debian stuff makes kind of the same pattern, and they always have a little bleeding edge of people running unstable or testing. And Ubuntu was up there because of the LTSs. And because of the long life of the LTSs, I can see that although these hosts can be patched, because they're not being patched. So you get a sort of like, you get a spike when it first comes out and everything gets deployed, and then it sort of turns into a kind of more of a hummock shape as fewer and fewer hosts are in active patch management. Sorry. Hopefully you've kind of got the idea of what I'm talking about. Any questions about that? No? Yes? So drop bear is actually there, thank you. I thought this was appropriate to talk about in Australia. So this is the oldest one, this is the newest one. Drop bear is usually used on embedded devices, not a running server, most like as I would think of a server that's in a data center somewhere in a rack. What I found really interesting about this is almost completely, so that's from 2010 all the way to January 2013, and this barely changes. So you can see it as a lesser one there, but from that I got the idea that if you put an embedded device in, it is not going to be patched. The other really interesting thing about this is that somebody that I'm not going to name is deploying a large amount of drop bear installs just recently in the last 3 scans. That's interesting for a rather worrying reason, in that this particular version of drop bear is from 2005. I couldn't possibly say. This is a nice conference. In Australia, you get kind of the same thing. You can see, the number of scans per country is not going to be the same, but you can kind of see that it might make the same pattern if we keep on scanning it. And you can also see that there's a big deployment of drop bear there, which I suspect will also go unpatched and which is also out of date. So Telnet, you can't really see much in Telnet when I looked at it. Most of the stuff is enter username, enter password, but pay attention. So it's what, early 2011? Yeah, mostly enter username, enter password. You do get some devices, which I've been keeping an eye on, because if you remember the drop bear example, it's unlikely that they're going to be changed. But if you see MikroTik there, v4.16, and the next one, you still have the top one is still that, but you have, 4.16, but you also get some you also get 5.6 and 4.10, and you also get the Chinese. Sorry, there was a big thing going for a while about whether or not it was safe to use them at all, because, oh my God, they're in our tubes, etc., etc. And so you can see device names, but most of the stuff you can't get any kind of idea on. Again, you can see deployments. Someone has just rolled out 10,000 netcoms. Go you. So MikroTik is, you can see it's now 5.14 is one of the most common ones. So that's either a new deployment or someone's patching their stuff. I'm going with a new deployment, frankly. At this stage, this is Australia, same thing. You get some device names, but mostly it's just password and user access verification. Okay, SMTP. This is the most common SMTP server in New Zealand and Australia over the last 4 years. If you remember going back to these slides, you can kind of see like you get a big few numbers up here, and then it tails off here, and you get quite a long tail of just ones, like just one-offs. With SMTP, most of them are in that tail, if they're not just service unavailable. This is quite hard. So this is just AD to ANE, it's AD to AE. And so every one of those is a custom string, and therefore I'm personally finding it quite difficult to parse. There's also that a lot of them look like that. Thanks. Oh yeah, sorry about that.
That's a Cisco fix.
Yeah, but when I'm trying to figure out just like a matrix of what maps to what, I don't want to have to go if then, oh God, it's a lot of stars. My God, it's full of stars, sorry. I should have thought of that one slightly earlier. But yeah, it has been maintained by other people who should just shut the hell up, that it would just take a weekend of Python, I don't believe it. HTTP. So again, remember how I said that if you turn the server tokens off, it is kind of blank to me. As you can see, there's a lot of very chatty Apache, but the vast majority of it is just says Apache. The same with New Zealand. So that's, it's 1st of November in Australia, Halloween in New Zealand. So yeah, the majority of it is but I can get, by correlating that with other running services, or I can identify another 30, 25%, depending. I suspect that will change probably on the scan run. I can probably get more of them if I correlate by the organization that they run from, or because they may have a set of Apache boxes and one of them is running FTPD. I can probably get more if I correlate that across organization and scan runs. This is the title on one page because the sorry, because the table just wouldn't squish any further. As of today, because I looked it up before in the conference wireless, this is, everything down here is stable. These are all considered to be legacies. So I don't necessarily have to have the operating system to know that something is not up to date. As you can see, there's like 39,000 of the most recent one, but I also suspect that's a new deployment and they will slowly rot back. So that one probably would have been bigger back in the, that would have been current back in the day and then deployed, and same with these ones. HTTPS, it's mostly similar to HTTP, but one rather large difference is that the older the version of Apache IIS that you're running, the less likely it is to have an SSL component, which is kind of interesting if you remember this here, where you have the long tail of stuff that's out of date. And the older that gets, the less likely it is to have SSL on it. So I used IIS for this, sorry about that, because it made the clearest graphs. So you can see here that's blue is port 443, orange is port 80, and this is December 2011 in Australia. You can see these, the older they are, the flatter or the less records I have for port 443. And you see those, it's not being kept up to date. Again, that deployment is falling behind. And so a year later, you can still see there the later versions are still the ones that are unlikely to be running SSL. And you can see here, those roughly correlate there, port 80 from a year ago, sorry, from 2012, 2011, but those don't correlate at all. The blue, the yellow and the blue just do not match. Same with, what was the point here? I'm pretty sure I had one. Oh yeah, I thought that this was maybe a new deployment here, and of course you can see, and I think the number, you can't really make it out on this graph, but the numbers for 8.0 are pretty much the same. So percentage-wise, the older your web server is, the less likely you are to have SSL on it. Port 445. The large majority of this was Windows machines, and so it's kind of, I got away with the IIS example, but I figured like putting too much Windows stuff in here was probably going to get me in a bit of trouble. I have spreadsheets. Please don't ask me about my spreadsheets. I don't want to talk about them anymore. But I did spot, again, a rather large deployment that tracked over 3 years of stable numbers of things in New Zealand. And you can see here that they're running Drop Bear, which we've established is usually an embedded SSH daemon. And there we have Micro HTTPD, which is usually an embedded web server. It says broadband router. And for some ungodly reason, they are all running Samba on the internet. Not only that, they're running Samba 3.3.4, which is from 2009. So by this stage, I was beginning to get very angry at everybody, including myself. We've only done one scan run so far of port 53, so I can't really say much about it yet, but the patterns do kind of check out a little bit. So I've made some predictions about what I'm going to find there when we keep on scanning it. There is a lot of very chatty Red Hat boxes. Thank you. They will be easy to track. So we'll see what kind of patterns they make in, say, the next year, the next 2 years, the next 3 years, assuming I don't get picked up on the way out of the lecture theatre. I'm unsure about this because DNS is usually considered to be a critical service. The internet relies on DNS. Thank you, Dan Kaminsky. You were very helpful. So I'm kind of predicting that they will get, say, updated a lot slower. They'll say lag behind SMTP, because everybody knows if your mail gateway gets owned and people can't get their email, and then there's running and screaming and monkeys, and people are like, can you tell the email's not working, I can't get my email, and you just want to go away and find a blanket and stick it over in your head. Not that I am remembering anything. So, you know, what next? I mean, there is a lot of data here. I am in no means an expert in trying to make patterns out of it. I'm not actually, to an extent, I don't want to say that the patterns I've got or the information that I've got is invalid, but I would really like to know if the theories that I've got will track for future scan runs. Can I now predict patching patterns? One thing I'm pretty interested in is quantifying the changiness of a particular service or service by operating system, or you could, even if you're particularly vicious, you could do it by organization. Does this organization patch their boxes often? How often do banner strings change in a, say in a methodical fashion? Does it go from the same string, say Apache blah to version Apache blah.1 to Apache blah.2? I think this should be possible to do, but I'm not a statistician. I am going to go and find one and make them help me, probably for free, sorry. I'm also not good at data visualization. Most of those graphs are from Open LibreOffice, and there will be more spreadsheets. But, so, there is a persistent problem with simple passwords. Everyone in this room knows that what we like to think of as stupid people set stupid passwords. Every time something gets hacked and ends up on Pastebin, and you look at the like password and 1, 2, 3, 4, 5, 6, blah, 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 and you know about that. I would argue that patching is kind of like our version of simple passwords. It's also maybe analogous to backups. We all know, and it doesn't happen. For the purposes of this research, I don't care why it's not happening. I'm just reporting trends that it's not. There's probably a lot of reasons that people don't do it, but it's out of scope. One of the most clear examples I got from about this was in Belgium, actually. 6 months between runs, and I think smack in the middle of it, Lenny went end of life. That's what it looked like before it went end of life. So, as you can not remember from the graph that I didn't have, there are little humps here where the main versions come out. There's like bits and pieces in between. At this scale, you can't really make out the little bump there from like the bleeding edge of Debian. And then Lenny goes end of life, and this happens. Drops by, I think it's like just over 100 boxes, so about 10% either disappeared or got upgraded. But you can see, but you can see here that the most recent boxes got patched. So I highly suspect that the longer a box goes unpatched, the more likely it is to keep on going unpatched, and it's just going to stay there, and nobody is going to want to touch it or do anything, because presumably either these are doing something important or everyone's forgotten about them until the hardware dies. But that is really, really depressing. Yeah, and again, I don't know if you guys can make it out, but you can see a little uptick here of people adopting the Debian bleeding edge stuff. This is not a new problem. This is 2001, 2008, the adoption of, sorry, I got this from the OpenSSH site and forgot to reference it. Sorry, you guys, you're awesome. Going from 1.x to 1.99 indicates backwards compatibility, so it will fail back to 1 if it has to. And you can see again, you have a long, like you have a big adoption there, and then you have a long tail of stuff. And it's not, percentage-wise, it's not that much, but it's just going to stay around forever. And then we've got the embedded problem, in which I strongly suspect that every time an embedded system goes in, it will never get patched again. Has anyone patched an embedded system at a large scale here? Anybody? ADSL router. IP camera. Yeah, at a large scale, like at an institutional level, does anybody ever done it? Anyone heard of people trying to roll it out, maybe?
We encourage customers to do it. What actually encouraged them? Gave them a web page where they could click.
Yeah. Remember that legacy system that I was talking about before? The one from 3 corporate changeovers ago?
They added a check for updates feature in the last rewrite.
So in the last?
The last one I bought, I logged into it, and the very first thing it did, you didn't have to go looking in obscure menus. It did I'm checking for updates. So
that was Netgear? Netgear?
Yes, Netgear.
Okay, so sorry, for the record, he said that he bought a Netgear and it was automatically checking for firmware updates as he installed it.
No, when I logged in.
When you logged in, sorry. So you would actually have to go in.
Yes.
So if it was auto-configured, then it would probably stay. Yeah. Sorry, small rant time. I think if Linux people are going to feel are going to feel smug about, say, Yorktown, where NT4 crashed an aircraft carrier, or British nuclear submarines getting Conficker, then, guys, you still suck. Sorry. These things are also on the internet right now. Some of the IP cameras that I could identify were running like 2.4 kernels and are going to be around forever because people think of it as an appliance. You plug it in and it just works. it just doesn't.
What about all the Android phones that get upgraded because the hardware can't run the latest version?
Android phones, when you buy, I believe, one directly from Google updates it for you, but I also don't believe that there's any incentive for manufacturers such as HTC or Samsung to keep patching it. I mean, they've sold you the hardware. Why do they? I don't think that they think there's any real reason to keep on patching, keep on supplying new versions of Android for particular hardware models. Every ADSL router ever is kind of a problem as well, because if you remember, the one had all of the Sorry, how am I going for time? Thank you. It had SMB showing on the internet. And that could have been a configuration thing. I believe some of those have got, you can enable the USB port and it will act as a file share, blah, blah, blah. But I already went into that, didn't I? Whoops. Yes. ADSL routers. This came out very recently. And if you remember the string at the beginning that I was searching for, where the first hit was full disclosure and the second two were how do I hack this, UPnP was in the string that I was looking for. And those are pretty much on the internet, well, on the Australian and New Zealand internet, to the best of my knowledge, those are all ADSL routers, and they are probably pretty much all vulnerable, and they will remain vulnerable until solar flares and zombies and the cyber apocalypse are actually taking out the entire residential internet. All of the residential internet connections would make a pretty good cyber apocalypse. So I have time for the waffly bits at the end. Yep. So who else would be using the starter? That would be bad people, pretty much. People with black hats, spooks, shadowy government organisations. The people involved with this project are motivated amateurs, but they don't get paid for it. It's as you can be bothered in your free time and your weekends, so if you burn out, then it's just not going to get touched. And it's nearly on version 3 now, and there's somebody actually probably actively working on it as I speak. I'm not saying that it's easy or that it's trivial, but this is not an insurmountable technical problem. And with the amount of money flying around that you could make from this by selling lists of targets and then selling the exploits, there would be a strong incentive for these people to do so. It is very possible to do that. And I believe there was something in HP Gary's mail spool suggesting that you could sell a list of targets by country code for a few $100,000 US, and subscribing to the O-Day exploits for those was a few $100,000 more.
What's the worst that could happen?
Samsung's bringing out a fridge that's got Android on it. Do you trust those ADSL routers to provide to an extent, I think that we're protected now because there are a bunch of them that are not doing network address translation. I believe if they were capable of it, a lot of stuff would just sort of start appearing on the internet. One of the other things that's quite visible is an uptick in home NAS solutions. You plug them in, they say, you should back up your stuff through the web interface. You do that, and then they turn up on the internet with readable shares on them because they just want people to back stuff up. That traffic is not getting blocked by the router, and it's ending up on the internet. And I think people are protected from that because some of them aren't. IPv6 is going to take all of that away, and it's going to add your fridge, your toaster. It's going to be a terrible thing. Yeah, what could possibly go wrong? Anybody?
Apocalypse.
Can I drink now? That would be great.
Quick question: does the scan on the SSL, does it pick up the certs, or
Yes, it does.
So could you correlate something like the certs that look like they're expensive and paid for and with big companies against the patch levels because they're hopefully getting PCI scanned anyway?
Right.
Or vice versa, because they're in giant, horrible
Other things we could look for are, say, MD5 collisions, so you have two legitimate certificates with the same fingerprints, or we could look for expiry dates.
I'll start this by saying, sorry if it creates more work for you. Would it be possible to do an analysis of what kinds of businesses are keeping certain patch levels? In other words, if you could presume that that's an ISP, that's a bank, and so on, and get patterns between different institutions?
You could look at the patch levels between institutions, yes. I have been doing a little bit of that, but it is it's ad hoc, and it's in no way predictive, and it seemed a little bit cruel, frankly.
Just an observation on the IPv6 front. Obviously people pretend that they're being protected by NAT, but what they're actually being protected by is a stateful firewall. You can have a stateful firewall with IPv6.
Okay.
And I suspect if it does actually get deployed into consumer things, then there will be a stateful firewall.
Yeah, what's going to make them put out a stateful firewall?
The fact that if they don't, everyone's going to get owned and there will be nasty news stories.
And that stopped, what, our Ministry of Social Development so far?
You're probably not trying to actively exploit any of these old patch levels that you find because that crosses a boundary.
No.
It would be interesting to see if you put naked, unnatted IP address on your on a server on the internet. If you were being scanned by from any of the IPs, which you're finding were at the older patch levels, you could infer that they've been hacked by somebody who's trying to send out spam mail or...
Yeah, that would be like making a network telescope or something, and then trying to pick up individual scans. Sort of like the inverse of this, I suppose. Is outside the scope, and it would be really interesting, actually, but I don't want to think about that, right? Too many spreadsheets.
Just following on from the IPv6 comment, second before last, every consumer router I've tested that supports IPv6 doesn't include a stateful firewall.
Oh look, I'm so surprised.
I haven't tested every consumer IPv6 router out there, but everyone that I have has no support whatsoever, so we rely on the fact that every consumer device itself does firewalling, which includes Windows, thank goodness, but nothing else that I've seen.
It's the sort of thing where I would quite like to be surprised, I think.
So system administrators tend to have a visceral, well, so do users, have a visceral negative reaction to self-updating software, self-updating firmware. Stuff when Firefox goes and tells me, oh yeah, no, I've just updated myself to the latest version behind your back, but you're cool with that, right? Which is worse, sorry.
I have no idea. When you figure it out, let me know.
I just did what was suggested when I came here, put up a small firewall before I plugged my laptop in, and with some grepping, I'm logging all the rejected packets, but with some grepping I got it down to other sites trying to call me, so threw away the broadcasts and the multicasts and stuff that wasn't going from my address, but I saw anyway for some reason. And there are a few, you see them, they seem quite consistent. They try. Well, I guess they do the regular retries before they give up. But we do see a few.
That's not us. Just saying.
Oh, there is. I don't know.
But yeah, that's interesting. I mean, like I said, I would be kind of surprised if other people weren't doing this. It's just from a non-malicious point of view, it's really interesting, and it's, I suppose, valuable if you are inclined that way.
I'm going to see 453 if they will use it.
Yeah. Yeah, we disconnect pretty. It's something about accessing in excess of your authority, so we disconnect pretty quickly.
Hi, so I love this sort of internet scale research. How can I help?
I have some spreadsheets. Think of questions to ask. That's like my biggest problem is that I know there's got to be really interesting stuff that's just like lying in that data, but it's much easier in some ways to collect it now than it is to manipulate it, and that's where I think I would either need some help or other people can do bits of it and think of their own questions to ask. So yeah, come down and talk to me afterwards.
If you've got a spare 100 gig of RAM,
that was the what can possibly go wrong face. Anyone else? No? Cool, thank you for actually thanks for turning up at the end of the day. I hope it was worth it.
Thank you very much, Joe. Any more questions anybody has? You can always catch Joe outside in the corridors. Joe, here's a...
Cool.
Thanks.
On to Linux Australia. Cool, thank you very much.
Thank you very much. Have a good day, everybody.